take main responsibility for is a form of retinal photography called optical coherence tomography. And using that technique or that methodology, we're able to actually measure the thickness of the retina at the back of the eye.
The changes in the thickness of these retinal fiber layers may actually parallel or potentially precede changes of neurodegeneration in the brain.
The eye is an extension of the brain, and the nerve cells that travel from the eye go all the way to the brain. First of all, the assessment is what we describe as non-invasive. So there's no injections, nothing involved that touches or can hurt in any way. There's no need to hold your eyes steady for long periods of time. We ask you to hold them steady for 10 seconds at the very most. It's easy to undertake as a patient. The patient comes in, sits in front of the instrument and pops their chin onto the chin rest here, head up against the head bar, and the operator just moves the optical head on the camera to focus it on each eye in turn and take the necessary images.
And there will be a sensation of laser light that is hardly even noticeable for just a matter of a few seconds, and you get a wonderful photograph of what your retina looks like.
Well, the assessment takes about a couple of minutes per eye, so we can actually scan most people within 10 minutes and they're done. Many optometry practices will have an optical coherence tomographer as part of their standard equipment. For that reason, it may make this technology more available and cheaper as well.
What makes it potentially unique as a window into the brain is that it is accessible with easily applied techniques. This will be a way of diagnosing it or potentially predicting risk for the development of neurodegeneration. It will be a way to assess it could be a way to assess what's going on in the brain, depending upon the nature of the results that come out of this. It's an exploratory study, one that has very low risk and very great potential.